everything at this stage that we know about integration, we're basing it off what we know from differentiation. We will get to the point, I promise, where we actually learn stuff about integration that's peculiar to integration and seems to have not much to do, at least directly, to what we've already established. But for now, we're still in this establishing phase. So we know how to differentiate a bunch of trigonometric functions. Actually, we know how to differentiate all of them. We're going to learn how to integrate most of them, as you'll see. So let's start. The simplest of the trigonometric functions is the base one. It's sine, right? Because cos is actually cosine. It's based on sine. So what we know about the derivative of sine is it is cos. Very good. So from this knowledge, we can make a statement about integration that borrows from this, right? What we do is we're going in the opposite direction. So therefore, the integral of cos would be sine. Do you agree with that? With one minor difference. Because we're integrating, the thing that comes along is the constant of integration. So let's add c right there. Okay. Now, the next one after that is the one we just had a look at, right? So the derivative of cos, it's a bit sneaky, right? Because there's a negative out the front, as we just established. So this is minus sine x. So when I go to integrate, now this is really, really sneaky, right? If I were integrating just regular sine x, that's not the derivative that we ended up with, right? So sine doesn't integrate into cos, it differentiates into cos. So I'm going to, before we write down the answer, I'm going to put an intermediate line here, right? We've seen this with when we've got weird coefficients and things like that at the front. Here, the coefficient I'm interested in is not a fraction or anything like that. It's just -1, right? There's a -1 I want to be there that's not there, okay? So what I'll do is I'll put one out the front and it kind of counteracts one I'm going to put on the inside. Are you okay with that? This negative out the front and this negative inside the integral kind of cancel out to give us the integral of sine x. So now from here we can say, firstly, that minus sign just hangs out the front, nothing happens to it. What is the function that differentiates into negative sine? It's cos, right? Now remember, we made this comparison between integrating is a bit like learning to write upside down, because you know how to write your name, but then suddenly everything's backwards. With trig functions, learning to integrate those are like learning to write upside down in a mirror, because you've got all these extra negatives flying around and you just have to be very, very cautious. It's hard enough doing these because we confuse them all the time, but now we've got all the reverse versions of them, so you have to be very, very cautious. Okay? We've got sine, we've got cos. What's next? Tan, thank you. So the derivative of tan x. So if you just did this on the previous one, so this is sec squared x. We can make a statement about integration by saying, well, the integral of that, what you ended up with, sec squared x, the integral of that with respect to x should be equal to, should take us back, right, to tan. Thank you. Good job, Sarang. Plus, of course, our constant. Now, as a notable absence on this list, right, we now know how to integrate sine, just like we knew how to differentiate it. We know how to integrate cos, just like we knew how to differentiate it. At this point in time, we know how to differentiate tan, but I'm just going to leave for now. We will return to this. The integral of tan. What is that? It doesn't appear here on the right-hand side. Yeah, do you see that? Okay, so I don't have, at least not on this board, the derivative that directly tells me the answer to this result. Okay, we will return to it shortly, but just sort of make a note for yourself. We haven't finished the list just yet. All right, now the only thing, Mrs. Lees, were you going to add something? The only thing I'm going to add to this before we actually get started on having a go at these is that all of these are kind of like the vanilla version of the trig functions. None of them involve any chain rule, right? So for example, under this integrals section over here, actually no, we'll stay over here. If we differentiate, let's go right back to the top of the list. If I gave you sine of 3x, to do chain rule on this, right, I'm going to deal with the inside, then the outside. So inside, derivative will be just derivative of the inside. Inside function's 3x. So it's just 3, okay? Inside's dealt with. Now I'll do the outside. As you guys said, that's cos. And don't forget the 3x is still 3x. So there I'm good to go, okay? Now when we write some equivalent integral statement with this, right? This integral. If I started with cos 3x, I know I'm going to end up with something like negative sine 3x, right? You see that? Sorry, no, just regular sine 3x. But watch out for this inside derivative. Just like with these guys over here, they're quite sneaky, right? Here I multiplied by 3. So what should I do here to compensate for that? I should divide. And then of course there's my plus c. And again, just like we've been doing over and over again, if you are unsure at any stage, you just look at it and you differentiate it. Just like this stuff you've been learning to write in a mirror, put it to a mirror and see if you got it right or if you got it wrong. We can generalize this, couldn't we? If we had the derivative of sine of any coefficient out the front, right? What would that equal? A cos AX, very good. And so you could say, well, there's an equivalent integral statement of that. Cos of any multiple of x with respect to x, it's not multiplication like you told me, it's division, right? So that's 1 over a, that's me dividing by a. Sine AX. Okay? Okay, now it's a bit unfortunate. I actually have one last one, but I have run out of space on my board, so hopefully you have space on your page. Actually, you know what? I don't even need to do that. I don't need the space. I'm going to pull on this. Let me bring this back. Do you have your reference sheet there? No. If you don't have your reference sheet, can you get it, please? All right, so actually I should zoom back out so you know where I'm looking. So this is your reference sheet, right? Page 1, then page 2, then page 3, and you hit calculus land. Now, we know a lot of this. In fact, we know almost everything on the left-hand side. There's some stuff down the bottom that's irrelevant to our course. But on the right-hand side over here, this is, as you can see, integral calculus. So this is the land we're living in at the moment. I want you to look carefully at just this second one down. Just have a look at this one for me. Okay, now what's going on here? When we integrate sine, you've already got it on your page, right? It goes to negative cos. Can you just confirm that's what you've got on your page, right? You integrate sine, it goes to negative cos. But then what's all of this f of x business going on, okay? This is reverse chain rule, but with trig. This is reverse chain rule, but it's with trig. If we took this guy and we differentiated it, right? This negative cos would turn into sine. Thumbs up, we know that. But then what happens with this f of x when you do chain rule on it? This is the inside function here. Do you agree? This is the inside function. So here comes the derivative of the inside function. And then the rest of it turns into sine. So if we were to do a concrete example of that, I'll leave that there. If we were to do an example like, I'll give you a really simple one, okay? 2x minus 1 sine. Can you see this? Now I know it looks messy, okay? But I've written this exactly in that form, okay? Look closely at this and this. Do you see the relationship between the two of them, right? In fact, please write this down. If it helps you, because it helped me when I did this kind of question, write, this is f of x. This is the inside function. And so this guy hanging out the front, I know it looks messy, but it's just the derivative of x squared turns into 2x. Minus x turns into minus 1. Do you agree? Writing this f dash and this f makes it clearer to you, I hope, that this is exactly the situation we're looking at. Okay, I'm trying to put this into that form so I can more readily recognize the answer. So use the reference sheet with me. What's the solution? What's the integral? Minus, yeah. I'm reading off the reference sheet at this point, right? Minus cos. Yeah, hold on, wait. It's f of x, isn't it? It's the f of x, which is this. That's why I wrote the f of x here. It's just like in quotient rule. You know how you're like, oh, this is u and this is v. Right? I write u and I write v so I know which is which. This is f, and this is f dash. So this is cos of f. And you can confirm this for yourself by taking this guy and differentiating it.